Good morning, good afternoon, good evening, depending on the time you come across this video as well as your location. Today we are going to discuss something very important, always as regards to construction. Alright, so today's topic we are looking at is structural stability. Structural stability. Now, I want you to understand that when we talk about structural stability, we are looking at the ability of the structure, to carry load effectively without any excessive deformation. Now, it's important that we understand some of the factors that will help to enhance structural stability in our structures. All right. Now, first and foremost, we are going to look at the first, having proper sizing of structural elements. Now, when we talk about proper sizing of structural elements, we are looking at the geometrical formation of our elements. All right. For example, we have our beam. The sizing here has to do with the cross-sectional area. Okay, the cross-sectional area. All right. It also talks about the length. Okay, the length. All right, the width in the case of our beam. All right. Now, for example, proper sizing here plays a very important role because, as you know, the various structural elements in our building perform differently. All right, depending on their positions. We have the slab. Okay, we have the slab. We have the beams. Okay, we have the columns. Okay, we have the staircase. We have the foundation. Okay, as the case may be. All right, so all of these are structural elements. Now, when we talk about the slab now we are looking at the length. Okay, let's take, this is the length, this is the width. Okay, then the thickness now. This is a kind of a section. All right, this is like a section XX. So this is section XX. So we'll talk about the depth. All right, so these are kind of the geometry of our slab. So if we have proper sizing of this slab, it will help to enhance the structural stability of this slab. All right, because as you know, it's a reinforced concrete element. That is, it is made up of steel and concrete. All right, now the steel now is what forms the internal strength of that slab, while the concrete brings the covers the steel. The concrete is there to protect the steel and also take care of compressive stresses that will emanate in the course of loading the slab. So also in our beam, we can have our beam in this manner. All right, then this is section Y. All right, we can have this is our section. This will be section YY. All right, then we have this is section of our beam. All right, this is a section of this beam now. Okay, this is a section of this beam. So it's important that we maintain the cross-sectional area of this beam as well as the length, because if you have less size of your beam, okay, that is not sufficient enough considering the span of that beam, that means there will be a problem. So that is why it's important we look at the sizing of our elements. That is one of the ways we can enhance structural stability. It's also applicable to our columns too. Okay, our columns. All right, let's say this is Z. This is Z. So you have your column. All right, you have your column section. You have your column section. Okay, this is Z, Z. All right, now these are the cross-sectional areas, the sizing of our elements. Now, when you have this sufficient enough, it means that you help to enhance structural stability, because these elements are there to carry load, transfer load. Basically, they will pick the load, transfer it. So this will enhance the load transfer pathway within the structure. So peradventure, the sizing of that element is not sufficient enough, it will bring a kind of, it will be deficient. That element will be deficient. Okay, the capacity to effectively transfer will not be sufficient enough, and that can lead to that element being defective. All right, so we must look at that very well. Then we'll also look at the load calculation. Okay, the load calculation. All right, because as you know, when we load during design, we try to come up with our loads. All right, we generate our loads. Now these loads are meant to be, these elements are meant to carry this load. So it's important that you design elements that that are capable or are able to carry that design load. All right, when you do that, you have enhanced the structural stability. Okay, so you must ensure that the calculated load, okay, is what is being subjected. Those elements are being subjected to those calculated loads. And in the course of design, you'll be able to come up with reinforcement. Like I said, it's reinforced concrete element. So basically, the design is all about trying to come up with reinforcements that can be able to carry the kind of enhance the transfer of these loads in terms of tensile stresses and all of that. Okay, so we must ensure that we don't exceed our load calculation, as in the load that we have calculated already for the structural elements. All right, that is also a way we can enhance structural stability. All right, so please, I'm going to stop here. Do well to follow this page if this is the first time you're coming across my video for more insightful contents as regards to construction. I will continue on this subsequently. Bye for now.